Hey coders, and welcome back to another video, and today we're going to be coding the QuickSort algorithm. Without further ado, let's get started. The first thing we want to do is have a method that calls or kicks off the recursive part of this algorithm. We'll say public void apply sort on an array of integers, and the recursive function will just be QuickSort. We're going to pass in the array 0 and array.length -1. This function, we're going to pass in the array, the low and the high indexes of that array. Initially, the low starts at index 0 and the high starts at the last index of the array. The whole reason is because we're worried about the pivot of the quicksort. That's how we sort everything based around the pivot. Let's go ahead and create the recursive function. So public void quicksort int array, int low, int high. Now for any recursion, you have to have a base case, or else your recursion will just always run infinitely, and that is bad. You don't want that. Our case is going to be whenever the low and the high indexes cross each other. So if the low is less than the high, that's fine. That means that we can continue on with our recursion. But if that doesn't happen, then we are done with that recursion on the activation stack, and we can move on until we are finished with all of the recursive calls on the activation stack. The next thing I mentioned that is important is the pivot. So pivot index is going to be equal to another method called partition array. We pass in the low and the high as well. The partition method is what takes all the elements that are less than the pivot, move it to the left of the pivot in the array, and all the elements that are greater than the pivot, move it to the right of the pivot in the array, and then the pivot is in the middle. So at that point, they're sorted from less than the pivot, and then greater than the pivot. Next, we then call quicksort again. So quicksort array, give it low, and then pivot index -1. We also have quicksort array, pivot index +1, and high. Remember that the basic difference between merge sort and quicksort is that quicksort will sort the elements before it has the recursive call, whereas merge sort will do all of the recursive calling, and then once it's done, as it goes back up and merging the array together, then it sorts the elements. Let's move on to the partition logic. It'll make a little more sense. We have private int partition, int array, int low, and int high. Now, as I mentioned in the video where I explained quicksort, the pivot is going to be the last element of that portion of the array. So if we have the whole array, it's going to be the last index. If we have like 3 elements of the array that we're partitioning, then it's going to be that third element. All right, so we're going to say int pivot is equal to array of high. So int I equals low -1. This is just used for some of the logic of swapping, which we'll see here in a minute. Now we need a for loop that goes over all the elements from low to high in this array and moves them either to the left or to the right of the pivot. For int j equals low, j is less than high, j ++. So initially j is equal to low, which is 0, and then the high is 4 for the first pass. If array of j is less than pivot, here in this array, j starts out at 0 and the pivot is 7. Well, 2 is less than 7. What we end up doing is we're going to increment I, and then we swap array I and j. Now we increment I because initially it starts out at -1 here, where low is 0. So now I is 0, j is 0, and we're just swapping 2 in place. It's not actually going anywhere because we want it to stay where it's at. This is just a little bit of like logic manipulation to keep it where it's at. Then the second time through where we increment j is 1. Now we say array at 1, which is 9, is that less than the pivot? It is not. So we don't do anything, okay? But j increases, so I is still 0, and now j is going to be 2. So j is now 2, is 4 less than the pivot. It is. Well, j is 2, we increment I, which was 0, so now it's 1, and we swap I and j. So I is 1, j is 2, we end up swapping 9 and 4. So now it'll be 2, 4, 9, 3, 7. And the last thing is we need to do one more swap. That is when we finally get to here, to this point, this for loop will take us to this point eventually. All right, but when we're done, we still have 9 here. The pivot is 7. We need to take 9 and move and swap it with 7. Say swap array I plus 1 and the high. And then we return I plus 1. And the last thing we need to do is implement the swap method. And this is something you really should know how to do pretty much by memory. So it's private void swap. You know, pass in the array, int A, int B. Now there are some other clever ways you can do swapping using like 1 or 2 lines, but generally you create a temp of the first array index, so array at A. Then you say array of A is equal to array of B. And now since array of A and array of B are equal to each other, we need to set array of B back to the temp value. And congratulations, you've just coded QuickSort. And now as just a quick test, add this initial array. We print that initial array, sort it, and then print out the sorted array. So when we go to print this, or we go to run this, we get the sorted array. Congratulations on coding the QuickSort algorithm and following along. If you have any comments or questions, put them down below. I'll be more than happy to get with you and help you out. I also have an explanation video of QuickSort that I'll leave up here in the top left. I'll see you in the next video and have a great day.